During the Lassine test, if we got nitrogen containing functionalization, that is Fuchsian blue test is positive, then we go for the nitrogen containing functional group test. If we got no Fuchsian blue coloration during nitrogen test, we don't need to test for the nitrogen containing functionalization. Now we will test for the nitrogen containing functional group, that is amino group. For amino group we will test solubility test, litmus test. For aromatic amine we do the dye test. For nitro group we perform the Mulliken-Barker test, and for amide group we perform the hydrolysis test. Let's see for the test for the amino group. First of all, we test the solubility check of amine. For this reaction, we need the sample and HCl, dilute HCl solution. At first, we take the sample in a test tube, then add dilute HCl in it. Here we can see that the organic compound is completely soluble in dilute HCl. We know that organic compound is not soluble in water because its polarity, but here we see that the compound is soluble in HCl because the amine group has basic properties, so they are soluble in HCl. This indicates the presence of the amino group in our compound. Another test for their acidity of amine group can be done using litmus paper. For amino group, aliphatic amine is more basic than aromatic amine, and this is proved by the litmus test. If you take an aliphatic amine, that is ethylamine, and another hand we take alcoholic solution of an aromatic amine, that is paranitroaniline, we will test two solution with red litmus. For aromatic amine, we can see that there is no sufficient change in the color of the compound. That is, red litmus remains red due to its less basicity. But in case of aliphatic amine, we can clearly see that the color of the red litmus becomes blue in presence of an aliphatic amine. Here we can distinguish among the aliphatic amine and aromatic amine. For less basicity of the aromatic amine, it cannot change the color of red litmus to blue. Now we will test for the aromatic amine. For this, we will perform the azodite test, which is a very common test performed in our daily laboratory practicals. For this, we need an aromatic amine, sodium nitrite solution, dilute HCl, and alkaline beta-naphthol solution. With this, we need ice bath for cooling, because the reaction should be performed in cold condition. The temperature of the reaction must be in between 0 to 5 degrees centigrade, otherwise we do not get positive result. For this reaction, we will take 3 test tubes marked test tube A, test tube B, and test tube C. In test tube A, we will take the sample that contains amine group, aromatic amine group, and dissolve it in dilute HCl. In test tube B, we will take sodium nitrate and dissolve it with distilled water and third test tube we will take alkaline beta-naphthol solution. These 3 test tubes must be cooled in ice bath over 5 minutes. After cooling, the solution B that contains NaNO2 in HCl is poured into the acidic solution of the sample. The solution is again cooled. Then pour the two mixture of the solution into the alkaline beta-naphthol solution in test tube C. Formation of brilliant red coloration confirms the presence of aromatic amine compound in the given organic sample. Can be noted that if the temperature of the sample during the reaction becomes greater than 10 degrees centigrade, the dye formed can be charred and it cannot form brilliant red dye. So, cool the reaction mixture properly in ice bath. Now for the test of nitro group, we will perform molecular marker test. For this reaction, we need a nitro compound. It may or may not be in presence of amine group. It may be aliphatic nitro compound or aromatic nitro compound. Both gives positive result in this molecular marker test. With this compound, we need concentrated HCl, ferric chloride solution, zinc dust, ammonium chloride, and benzoyl chloride solution. At first, we have to take the sample in 50% ethanol and water solution. Dissolve it in ethanol and add water to it so that it may be from 50% water and ethanolic solution. Then add pinch of ammonium chloride and zinc dust in it. At first we will add pinch of ammonium chloride, then we will add pinch of zinc dust in it. Now boil the mixture of the compound in water bath for 5 minutes. The nitro is reduced to hydroxylamine group and it will give us the positive result. It must be noted that the solution must not be bumped, so heat it gently and carefully. After heating for 5 minutes in water bath, the reaction is cooled. For rapid cooling, I am dipping it in ice bath. You can also cool it under tap water. The cooled mixture is then filtered into another test tube. To 1% of the sample filtrate, add freshly prepared tolerance reagent, which I have prepared during this reaction schedule. For tolerance reagent and warm it in a water bath. After heating of water bath, you can see that grey precipitate is formed, and here a slow but faint black mirror is formed. We can see that grey precipitate or black mirror type is silky. This confirms the presence of the aromatic nitro group in our compound. To another part of the filtrate, add 2 drops of benzoyl chloride and shake it. Then add 2 drops of concentrated HCl. To this mixture, add 2 drops of ferric chloride solution. Formation of red precipitate or coloration confirms the presence of nitro group. Now we will test for the amide group. For this test we need sample, NaOH solution, concentrated HCl dipped in glass rod. At first we take NaOH solution in a test tube. Then add the sample into the NaOH and heat it into the Bunsen burner. Here we can see a white fumes of smell of ammonia evaporates. When a glass rod dipped in concentrated HCl is taken into the mouth of the tube, it becomes white fumes. It indicates the presence of amide group in our organic compound, and the fume of ammonia produces white fumes of ammonium chloride in presence of concentrated HCl. Thus, presence of amide group is confirmed.